Let me ask you a simple question. Have you ever tried learning an algorithm like Mershot or Quicksort and felt like you are memorizing steps instead of actually understanding what is happening? Most students learn algorithm through code, diagrams, or videos, but algorithms are dynamic processes. They move, divide, and interact step by step. Still, we try to understand them through the flat 2D explanation. This creates a gap between seeing the code and understanding the logic. To solve this, we build something different. Today, we are excited to present AlgoVerse, a platform where algorithms are not just written, they were experienced in a live 3D environment. Hi everyone, imagine trying to understand recursion by reading only code. You try to imagine function calls in your head, but it becomes confusing very quickly. Our brain understand movement and 3D visuals much faster than plain text, but algorithm education still depends mostly on text and static diagrams. So we created AlgoVerse, where students can watch algorithms come alive and interact with them in real time. So, the biggest challenge beginner face while learning algorithm is the cognitive gap. Concepts like recursion, stack memory, and data movement are invisible. Student can see how data splits or how functions call grow deeper. Because of this, many student and uh, um, because of this, many students end up memorizing steps instead of truly understanding the logic. This makes problem solving difficult later. So these were the challenges faced by the beginner. For example, recursion, the difficulty in visualizing the call stack and data vision, and visual spatial learning and passive learning. So before building the AlgoVerse, we studied the current platform. First, VisualAlgo.net is considered a strong visualization tool, but its design feels outdated. It works only in 2D, and interaction is limited compared to modern learning tools. Next, platforms like LeetCode and HackerRank are excellent for coding practice and improving syntax skills, but they do not help students understand how algorithms actually move data in memory. They focus mostly in the solving problem. Then there are YouTube tutorials. They explain concepts well, but learning there is passive. Student cannot pause algorithm mid steps, inspect variable, or test their own inputs easily. Because of this limitation, students still struggle to build clear conceptual understanding. To solve this problem, we design an interactive 3D logic laboratory, AlgoVerse. AlgoVerse transforms algorithm learning into a gamified and immersive experience. Instead of showing data structure as a charts, or we treat them as physical objects inside a 3D space. We build this using React 3 Fiber, which allows smooth animation and real-time interaction directly in the browser. This platform is clean, modern, and runs smoothly at the 60 frames per second, making learning engaging and fun. Building AlgoVerse required combining advanced web technologies with performance optimization. We use React 3 Fiber to render 3D graphics efficiently in the browser. We use React use ref hooks to bypass unnecessary re-render cycle and maintain smooth animation even during deep recursion. We also built a custom smart sleep promise wrapper to manage pause and resume functionality while keeping algorithm execution stable. The entire platform runs on lightweight web technology without using heavy game engines. So this will be our prototype implementation, how this will be look in the web page, and this will be the libraries which are available, and it will be available for all the questions which are available in the lead code. We can build for any question that are available. This will be the showcase of the majority element which are the major problem which will be asked in the interviews. So this I will provide the link in the demo or the link section. So AlgoVerse is just the beginning of our vision. In the future, we plan to add graph traversal algorithm like BFS and DFS and AI code generator that help students build and visualize their own algorithm. Our goal is to bridge the gap between the abstract programming logic and real understanding. AlgoVerse makes learning data structure iterative and enjoyable. Thank you.